Good morning, students. In previous video session, you have learned the relation between momentum and kinetic energy. Also, you have learned the work energy theorem. In today's session, we are going to have a new topic. It is one of the important topic like our last topic, work kinetic energy theorem. In this unit, there are few important questions. And that one of very important question is work kinetic energy theorem. And what we are going to see today is also one of the important 5-mark question. It is about the potential energy derivation. You know, potential energy derivation we are going to see. So you all know that there are two types of energy. There are two types of energy: kinetic energy and potential energy. Energy means, you all know that from your smaller grade you are studying. Energy means what? Capacity to do work. Energy means capacity to do work. And kinetic energy and potential energy are the two types of energy, and kinetic energy means what? Which possessed in moving object. Any object which is in motion, it exists what? Kinetic energy. So it possesses kinetic energy. So any object which is in motion, example also you know, any moving object, you can tell all the moving object possess what energy? Kinetic energy. And the second type of energy, potential energy. In potential energy, there are so many types of energy like gravitational potential energy, elastic potential energy, electrical potential energy, nuclear potential energy, gravitational potential energy. Then many types of potential energies are there. Potential energy means any object possesses its state or size. So example, you see this object, it is in its position. So we can tell that it possesses potential energy. You see, this is what? This chalk possesses potential energy. This blackboard possesses potential energy. Like every object around us which is in its state or in some size, some shape. So all these type of object possess some types of one type of energy which is called what? It is called potential energy. So, energy associated with its position, that is what? Potential energy, simply we can say. It's what I told, around us, all the object which is in its state or size or its shape. So, all these type of object possess what energy? Some type of energy, either kinetic energy or potential energy. So, all the moving object possess kinetic energy, all the object which is in its state possess potential energy. So here, in our derivation, assume that one object which is at the rest. This is the initial position of the object P you can keep. So, assume that you are moving this object. For example, another example you can tell, this blackboard. This blackboard is down. Assume that the blackboard is kept down. You are lifting this blackboard upward. You are lifting this blackboard upward. So, without applying the force, work cannot be done. So we are applying a force, external force on the object, so the what also some work has to be done to lift this board upward. Like that, assume that an object which is at rest, this object initial position is here, and its initial position, from this initial position this object is lifted here. So from this initial position, this final position, the object is shifted. You can keep to value OP. So from the point O, the object is lifted upward. Assume that. So if you want to lift any object, this is the object initial position, you are lifting this object upward. If you want to lift this object upward, some force has to be applied. When I am applying the force on this object, some work has to be done. When this work is done, this object is displaced. So this is what we are saying, potential energy. What are potential energy? Its definition is given in page number 176. Potential energy of an object at a point P. How you can define? How you can define? It is defined as the amount of water work done by an external force. So this is what you are applying the external force on an object to do some work. I am applying a force on this object, so some work has to be done. So the object lifted from the initial position to final position. This is what we are saying, potential energy. So now it possesses potential energy. So the amount of water, amount of work done by an external force, by applying an external force, some work has to be done to move an object in a constant velocity from its initial position to final position. In its initial position, the potential energy is what? 0. In this initial position, potential energy is 0. From this initial position, this object is lifted upward by using an external force. Due to this external force, some work has to be done. Work has to be done means what? It is lifted. Now there will be some potential energy to moving this object from its initial position to final position. Now what are? There must be some energy. That is what potential energy is. So how we can define the potential energy? The potential energy at a point P can be defined as what? The amount of work done by an external force to move an object in water, to move an object in a constant velocity. You are moving this object in a constant velocity from its initial position to final position. At the initial position, its potential energy is always what? 0. This is what the potential energy definition. Now you see, assume that potential energy near the surface of the earth on topic is there. That is also included with this. First 5 mark question means first you have to write this definition, page number 176. This potential energy definition you have to write. Then you have to write, continue that 4.2.5. So first you have to write the definition, and potential energy symbol is U. The formula, integration FA dot dr. FA dot what? FA dot dr. So from this formula, you see, I told you all the object which is in its position or a state or a shape or size, it possesses what? Potential energy. Now there are so many various type of potential energy. Here some types of potential energy given for you. First one is gravitational potential energy. This one is gravitational potential energy, you can tell. You see, lifting an object upward. Lifting an object upward. So there must be some gravitational force which is acting downward. Against this gravitational force, we are lifting this object upward by using an external force. So there is, due to that force, there must be some acceleration upward, and downward there will be what? Gravitational force. So we can tell now it possesses gravitational potential energy. And the second type of potential energy is, assume that you have a spring or rubber band. You are stretching the spring and releasing. You are stretching the rubber band and releasing. When you stretch, there is a stretching force. Due to that stretching force, there is a what? Displacement. So what? By using an external force. By using an external force, there is here what? It is stretching means some acceleration is there. So spring elongate, you can tell. So the spring possesses elastic potential energy. Spring possesses what energy? Elastic potential energy. Like that, electrostatic potential energy, another type of energy due to electrostatic force on charge. You know, there is a charge flow in a conductor always. So this charge flow is due to the electrostatic force. That is what electrostatic. So that possesses what? Electrostatic potential energy. These are the three types of potential energy which is given for you. Still many are there. You have learned in your lower grade and all. Now go through these three types of potential energy. What? Gravitational potential energy, elastic potential energy, and what? Electrostatic potential energy. Now assume that one object is here. Now assume that one object is near the earth surface. One object is kept near the earth surface. This object is lifted upward for a height h. So when an object is near the earth surface, here there is a what? Gravitational force. Gravitational force mg which is acting. Now you are lifting this object upward. This gravitational force is acting downward and acceleration is upward. So acceleration is due to the external force. So here what? This mg means what? Gravitational force. So you can keep Fg. Now you have learned that the unit vector. What is this? X, Y. This is what? Minus Y, you can tell. Y minus Y. What? So vector, this is I, this is J vector, this is minus J vector. So downward acting what? Downward acting Fg is acting what? Minus mg. Fg, gravitational force here what? Minus mg. Minus mg means why minus here? Because minus y direction. Vector direction is where? Minus j. Downward. This gravitational force is acting this direction, opposite to the acceleration. Opposite to the acceleration. So Fg is minus mg means opposite. Fa is what? Plus mg. Okay. Now you can use this formula. What is that? U equal to Fa. Fa means what? U equal to magnitude of Fa, magnitude of dr. Magnitude of dr. So, what is this Fa? Fa means what? Mg. What is this dr? When you are writing the dr, you can write with its component. This is magnitude of Fa, magnitude of dr. So, you can write with the cos component. Dr cos theta. Dr cos theta. Theta means what? This cos theta is the component, this component. That is what we are taking. Dr cos theta. Dr means what? The displacement. The displacement which is happening this direction. So this component is what? Cos component. And we are using dr cos theta. Now substitute this. This you can take equation 1. This one you take 2. Now substitute this 3, 4 you can take. Substitute 3 and 4 in equation 2. So what will come? U equal to integration Fa. Fa means mg and dr. Dr means what here? Dr cos theta. Now, listen here. This displacement dr is from the position what? Initial position to some height. So this position. From an initial position to another position. So, from this initial position, zero potential energy, it is lifted to some height. So, this is a limit we can use to integrate this. So, you can put here lower limit to 0, upper limit h. Lower limit 0, upper limit what? H. I think you have understand this. Object is here. Now the potential energy is 0. We are lifting this object at the height h. Now from 0 to h you are lifting. That's what we are integrating. So from this position to that position it is displaced. So we can integrate this equation. So when we are integrating this equation, before integrating, we have to find the theta value. You see, this is the object. We are lifting this direction Fa, this direction. Now, acceleration, applied force, displacement is same direction. So, theta, there is no angle between them. Suppose there is no angle between this applied force and what? And the displacement. Suppose, assume that one object is like this. You are applying a force on here. So the object moves like this. Then there is an angle produced like this. So applied force and displacement in different directions. So angle produced. Now there must be some theta value. But here force also, displacement also what? Same direction. So force and displacement the same direction means angle theta value is what? Theta value is theta is equal to 0 degree. 0 degree. So theta 0 means cos 0. Cos 0 equal to 1. Now use this. u equal to 0 to h mg dr. Cos theta become what? Cos 0, which means 1. 1 into dr. Now integrate this displacement only we are going to integrate dr. So u is equal to mg, you take outside, integrate dr for the limit 0 to h. Now integrate this, u is equal to mg, dr integration is r. Dr integration is r. Limit 0 to h. Apply the upper limit. So u is equal to mg. Upper limit is h minus lower limit 0. So u is equal to mg h. mg into 0 is what? 0. So u is equal to mg h. This is what the potential energy derivation, and it is one of the important 5-mark question. So you can refer the page number 176 and 177. This potential energy derivation is there, one of the important 5-mark question. So again listen here. First you have to write page number 176, definition, potential energy definition. Definition is what? Potential energy of an object at a point P is the amount of work done by an external force to moving an object at constant velocity from its initial position to final position. At the initial position, potential energy is 0. You have to write this definition first, then mathematically one equation is given, u is equal to Fa dot dr. The types of potential energy, it is a separate question, 3-mark question. What are the types of potential energy? Yeah, here given gravitational potential energy, elastic potential energy, and electrostatic potential energy. Gravitational potential energy means what? Energy possessed by the body due to gravitational force. Then elastic potential energy means what? Energy due to spring force. Then electrostatic energy due to what? Electrostatic force. So these are the types of the potential energy. So in this 5-mark question you can write the first the definition, equation. Now potential energy near the surface of the earth, 4.2.5 also you can continue. You have to write up, you have to draw this diagram. What is acting upward? Fa, and downward acting is Fg. Downward gravitational force mg, upward acceleration plus mg. Why plus mg minus mg? Gravitational force is acting downward. So what vector we are using is what? Minus j vector. So that we have to use. So downward minus mg means opposite, upward what will be there? Plus mg to balance that. Now you can find out this. What you can write this equation in terms of page number 177. It is there. Fa dr cos theta. Now this cos theta we have to find, theta we have to find. Theta how we will find? Yeah, the force, external force which is applied and the displacement in the same direction. So theta value is what? 0. So cos 0 is what? Cos 0. Cos 0 value is what? 1. Cos 0 value is 1. So you can substitute the remaining value. What? Fa. Fa means mg. Then dr cos theta you can take up. Then put the value. Integrate this for the limit 0 to h. Why 0 to h? From potential energy 0 to some height it is lifted, so 0 to h. Now you can integrate this, integrate what? dr. Take mg outside, integrate this dr, then apply the limit. Integration of dr is r. Apply the upper limit, lower limit, h minus 0. So u is equal to what we will get? mg h. This is what derivation for potential energy. Now example 4.8 you can practice. The next thing is page number 183, law of conservation of energy. I am taking along with this. From your smaller grade you are studying this law of conservation of energy. You see, an object is what? Law of conservation of energy. Page number 184, law is there. Only you have to learn this law. It is very important 2-mark law. Very simple. You can learn this. You see, now the choke is in this position. Now the potential energy is, it possesses some potential energy. It possesses some potential energy. Now I am throwing this downward. When I am throwing this downward, the potential energy, when it is in its state, in its position, it possesses potential energy. When I am throwing down, it is moving. Moving means what type of energy it possesses? Kinetic energy. So, first potential energy, when it moves, what energy? It possesses kinetic energy. That means what? Potential energy is changed to kinetic energy. Again it is at rest. When it is falling down, when it is hitting the ground, it possesses some other energy. You see, when it hit, it produces some heat. When it hit the ground, it produces some sound. So, the initial potential energy, when it is moving, change to kinetic energy. Again, when it is hitting the ground, that kinetic energy changes to heat energy, sound energy, as well as what again? Potential energy. This is what energy is changing from one form of energy to another form of energy. Potential energy is changed to kinetic energy. Again that kinetic energy is changes to what? Potential energy plus some heat energy plus some sound energy. So, energy cannot be made or destroyed. That is what? Energy cannot be destroyed or made. But it can be changed from one form of energy to another form of energy. The total energy is what? Isolated during this transfer. You can see in page number 184, energy can neither be created nor destroyed. It may be transferred from one form of energy to another, but the total energy is isolated. It remains what? Constant. The system remains constant. That's what I told. Potential energy changes to kinetic energy. Again, this kinetic energy changes to potential energy. Then what? Plus some heat energy or sound energy. All this energy transfer. During all this energy transfer, what? This energy is not destroying, but it is changing from one form to another form. That is what potential energy changes to kinetic energy. Kinetic energy changes to some other forms of energy. The total energy is always conserving. This is law of conservation of energy. Very, very important 2-mark question. Law of conservation of energy. What? Energy can be Energy cannot be made or destroyed, but it can be changed from one form of energy to another form of energy. But the total energy of the system is conserved, or we can tell it is constant. So students, today I have taken on 5-mark question and on 2-mark question. These two are very, very important questions in from the fourth unit. So if you have to practice this potential energy derivation, it is very small derivation, and you have to learn law of conservation of energy. This is your homework for today. Practice this. See you all. Bye bye. Thank you.